Hello, geometry students. I have been racking my brain for what the next thing should look like for you as you work through the standard 16 surface area and volume. Some of you that have been working have already done some IXL work on prisms and cylinders and spheres, and you've worked with surface area and volume for those three. Basically, it's knowing a formula and then knowing how to apply that to a given problem. But what I'd actually like to do, I've been thinking, do we do more IXL? Do we start talking about pyramids and cones? Do we go to Khan Academy? What do we do? And what I'd like to offer right now is a little bit different approach where we're not necessarily worried about doing so many problems, so much extra practice, but where you actually get to start applying these surface area and volume ideas to some interesting questions. You might not get them exactly right, or you might not get an answer that's completely logical, but I'm very interested in your thought process, and I want to start the back and forth between you and me, emails, videos you make and send to me, things that you write out and you take a picture of and you send to me. I want to see what we can do with this. So I have a couple of questions. I haven't really prepared a lot for this video, but I'm just going to show you what I'm thinking. First off, I went out in my garage and I found some Pepsi cans, all right? And my first question for you is, well, what geometric shape or geometric solid would be a good model for a pop can, right? And hopefully you recognize that would be a cylinder. So set those down there. So this idea of a cylinder has a circle for a top. Turn so I can circle for a top, circle for a bottom. Right, we talked about what a cylinder was, okay? Right? Pop can. All right. So, what interesting questions could we ask about this? Well, we might say, well, what's the volume of the pop that you can fit in here, okay? And so you could go about measuring maybe in centimeters and find the number of cubic centimeters in a can of pop. There's your first question. How many cubic centimeters are in a can of pop, approximately? Next, you might ask the question, hey, if I'm in charge of making these pop cans, approximately how much aluminum do I need to make this? That would be a surface area question. So, next question, what's the surface area of a pop can? Approximately in square centimeters. What about square inches? What would be the surface area in square inches? A couple more questions there. You might extend this further and say, you know what? The place that makes pop and pop cans, they don't make just one. They make lots of them. And when they ship them, a lot of times they turn them sideways and they put 12 of them. They put 6 of them down and they put 6 of them on top and they put them in a case of pop, right? A 12 pack, right? Have you guys seen those? They're this, what we would call a rectangular prism. They put them in a rectangular prism. There's 1, 2, 3, 4, 5, 6 on the bottom. 1, 2, 3, 4, 5, 6 on the top, right? So maybe another question, how big of a container does a 12-pack for Pepsi need to be? What's the volume of the box? What's the surface area of the box? And one other question, this is kind of fun. When you put all those cans inside of your container, inside of your box, how much empty space is in there? Is there more empty space than space filled with pop cans? I don't know. It's an interesting question. I would encourage you to try it. And by try it, I mean take a piece of paper, start drawing stuff out. Find the volume of these things. Show me, you scribble, show me pictures, show me work. I want to see it. I want to see you send me a picture back of what you've tried, even if it's just part of it. Show me what you tried. Show me what you've come up with. An interesting question, or a bunch of interesting questions, I feel like, better than just doing some IXL or Khan Academy. One other thing that I'll throw out there, And this isn't just because I'm hungry, but my wife went to the store the other day and she got some of these yummy ice cream cones, right? And here's the question, right? What is a good math model for this ice cream cone with ice cream on top, right? Maybe it's a cone. I know I didn't ask you to necessarily find surface area and volumes of a cone yet, but you could look up the formulas and do that in the same way that we've done these other things. What about that on top? Looks like either almost a whole sphere. Sometimes these are only like a hemisphere, like a half of a sphere on top, right? So you might ask the question, well, I should ask you, what question could you ask that would be interesting to know about this? How much ice cream is there? What's the volume of the ice cream on top, including everything inside the cone? How much cone material is required to make this? Knowing that on the top part, there's no cone. It's just around the side. How much wrapping? If, like, this is just a wrapper that wasn't real tight, but what if you did a tight wrapper around the whole thing? How much wrapping would you need? Okay. If you put a bunch of these together, okay, in a box, how big would your box have to be? Could you minimize the surface area of that box by turning these a certain way? I don't know, all kinds of interesting questions. So I challenge you, run with this. See what you can do to explore surface area and volume of a cone, of ice cream, of pop cans. Find something on your own, right? What's something else you see around your house that you think, hey, it would be interesting to explore the surface area and volume of this? And I'm going to ask this question about it, whatever that is. So I challenge you, get after it, see what you can come up with. Contact me, and we'll have a good time going from there. Thanks, guys. Oh, yeah.